Here's a scenario that I've outlined for Matt. There's Matt.
Wow.
He's on a camping trip. This is a river near his campsite. Are you ready? You spontaneously human combust, and you are now on fire. Draw the path that you would follow. Put yourself out.
Gonna go that.
Thank you very much. Golf clap. Okay, Matt, what can you tell us about that red segment you just drew? Any significance?
It's a line.
No, it's a line segment.
Segment.
Yeah, good. Anything else?
It leads straight to the river.
Straight to the river. Okay, now I'm going to play with a little bit of vocabulary. Is this not straight to the river?
It is.
It is. Why the red one? Why did you choose the red one?
It's the closest way. It's the quickest.
How do you know that? Or what's significant about that red segment?
It's short.
How do you know that? Now think geometry here. Forget about setting on fire and hair burning and the smell that goes along with it.
Like,
What I'm wondering is, how do you know, and I know you're not thinking rational because you're on fire, you're just running, but how do you know that the red is shorter than any of these other green segments that I can draw to the river?
something to do with the Pythagorean theorem.
It might.
I think the green line's the hypotenuse, which is the longest line.
Before the green lines can be hypotenuses, not hypoteni, we need something else. And what piece of information are you missing?
That the blue line.
Yeah?
How long is it?
Nope, we don't care how long the river is. Nor are you going to care. You're on fire. You just want water. Water good, fire bad. Because you use the word hypotenuse, which is outstanding, except you're missing one piece of information.
The legs.
You're also using the word legs, which is good, but you're still missing one piece of information.
I'm out of ideas.
I understand. Caroline?
You need there to be a right angle.
So, I think really Matt needs to be applauded here because he bursts into flames, he's on fire, and he still thinks geometrically. So let's give it up for that. So he's on fire, his hair is melting,
Wait.
and he runs to the river, and he's thinking to himself, I want to get to the river as quickly as possible along the shortest path. And he realizes that I should run perpendicular to the river because all these other paths are longer because, you said before, why are the green segments longer than the red segments?
This is a hypotenuse.
Good. The green segments are all hypotenuses, which are longer than either one of the legs, and he chose to run along the leg of this right triangle. Well done, Matt. Okay, after that lengthy explanation, what we found is that the shortest distance that Matt wants to travel to get to the river is along a perpendicular to the river. Everybody good with that?
Yeah.
That's something you want to write down. The shortest distance between a point and a line is a perpendicular. Now what we're going to do is take that idea and calculate some distances. We're going to calculate the distance, as it says on the top, between a point and a line.
What is it?
The shortest distance from a point to a line.
The distance that we measure, so hold on. The way we measure the distance between a point and a line is along a perpendicular.
Wait, what?
Darn it.
It just changes it.
That's why we have erasers.
Wait, can you say that again? 'Cause I...
The shortest distance from a point to a line is perpendicular.
Did you get all that?
No.
Say it again, Franny.
The shortest distance between a point and a line is a perpendicular.
There you go. So now, we're going to take some points and put them on a coordinate plane. We are going to use the point negative 4, 0. And we want to calculate the distance between the point negative 4, 0 and the line y equals 2x minus 2. And we're not going to graph it because graphing it will just cause problems. Because if you graph it, you're going to want to count things, and counting things doesn't really apply here. However, I will do a sketch, okay? Just so I can keep track of what's going on. So let's pretend this is my line, and over here is a point. So this is negative 4, 0. Let's call that point M for Matt. And here's the line, which we'll call y equals 2x minus 1. Or 2, I mean. I didn't change the point. Or if you prefer, we can call it lowercase r for river. And based on what we learned with Matt, the distance we're going to calculate is going to be this distance, which is perpendicular. We'll call that d. So once we find d, we have the answer to the question, because that is the distance from the point to the line. Understand the concept so far?
Yeah.
Good. Let's do some algebra. I'm going to name this point. Matt's going to name this point. What do you want to call that point, Matt?
C.
C for cat?
Yeah, sure.
Well, what did you, why C?
I don't know. I just let it pop to my head.
Okay, I see. Yeah. So if I can find C, I'm good to go. Because then I just need to do the distance formula between M and C, and I'm good to go. Finding C, however, is the entire gist of the problem. To do that, I'm going to find the I have the equation of the blue line. I'm going to find the equation of the red line. Even though it's a segment, we can pretend it's a line. Find the equation of the red line. Once I find the equation of the red line, then I can find... Thanks for coming, everybody. Good luck. See you later. No, sit down. It's not the period being over.
Wait, what that was?
I have no idea.
Prank. It's just a
I
prank,
am
bro.
so
Mom's got pranked on.
So, as we learned from Matt's little fire experiment, the red segment is perpendicular to the blue segment. So, what is the slope of the perpendicular line? Tricia. What's the slope of the blue line? And so what's the slope of the perpendicular line? No. Brandon.
Negative 1/2.
Negative 1/2. Change the sign, flip it over. I'm trying not to have my shoes squeak, so I'm walking on my tippy toes. We need two things for the equation of a line. What are they? Slope and point. Very good. Do we have a point? Yeah, right here. Therefore, the equation of that red line is y minus 0 equals negative 1/2 times the quantity x plus 4, which, since we're all big people here, would be this. Okay, everybody with me so far? Question?
How do you get negative 1/2?
Perpendicular reciprocals, flip it over, change the sign. Reciprocal of 2 is 1/2. It's positive, make it negative. Everybody good now? Okay, good. Now we need to find C. What's special about C? C is the point of intersection between the blue line and the red line. How do I find the point of intersection between two lines? Somebody said it. System of equations. Correct. Why are you all whispering? I want to find the point of intersection between 2x minus 2 and y equals negative 1/2 times the quantity x plus 4. How? What method would you like to use? Substitution or elimination?
Substitution.
Substitution would work wonderfully. 2x minus 2 is equal to negative 1/2 times the quantity x plus 4. Distributed property. Multiply everything by 2 because I'm scared of fractions. 4x minus 4 is equal to negative x minus 4. Bring that over to have 5x is equal to, add 4 to both sides. Uh-oh. No, I'm okay. 0. So x equals 0. I'm not afraid of 0. How do I find y?
Plug 0 in.
Where?
It's any of the equations.
I don't care. Let's do this guy. So y is equal to 2 times 0 minus 2. Notice I'm showing the plugging in. And later when you're using your calculator, you still show the plugging in. The math is pretty easy. Y is equal to negative 2. Therefore, C is at 0, comma, negative 2. And it? Question?
I'm confused on like the blue part. Like,
Solving the system?
yeah, how'd you do that?
Substitution. They're both equal to y, so I set them equal to each other.
Alright.
Okay?
Oh,
We're almost done. Now I want to know what the distance is, and I'm finding the distance from M to C. And since I love technology, then you're going to fire up your calculators. It'll be good practice. Pergam. Distance. And we're finding the distance between what 2 points?
M and C.
M and C. Negative 4, 0, and 0, negative 2. And that distance turns out to be distance turns out to be. Give it to me. Which is not an acceptable answer because you would simplify it to be
5
2 root 5. Or I'm feeling better about a decimal version because we're talking about Matt running to the river. How far would Matt have to run? Oh, cakewalk. 4.47 miles. Not too bad, Matt. You'll be okay. Okay.
4 miles.
Now, there's a couple things to look at in this problem before we move on. The first thing is the content. What did I do to find the answer? Understanding what I'm doing is taking a line and a point. I'm going to calculate the distance along that segment. I have to find that point, which I called C. And I found that by setting up the equation of the red line and then finding where the red line and the blue line intersect by solving the system. The braces is what indicates that I'm solving a system. And once I found that answer, then I did the distance between those two things. That's the first part. The second part is noticing how I showed work. I need to be able to follow your work, so things have to make sense. Everything is clearly labeled. I know what that line is. Now, maybe you don't want to use colors, maybe you can, but you're on Notability, so you can use colors till you throw up. I mean, there's a gabillion to choose from. Who's updated Notability, by the way? Nice, nice. So those of you that can, you have a whole bunch of new colors and you can do the straight segment thing, that'd be great. Solving the system, showing the system setup, showing how you solve the system to find X, how you use the system to find Y, showing the plug-in for Y. Now I know that where that point is, and then I calculated the distance from M to C. Don't just give me an answer out of nowhere. Tell me where this answer came from. I found it by finding the distance from the point M to the point C. And I'm assuming you're doing that on your calculator because you shouldn't have to do the distance formula by hand anymore. Okay? We clear on that? Everybody good, because it's going to get ugly in a second.
Uh-oh.
It's all real.
We're all good?
I think.
Okay. Next problem. We're going to tweak it a little bit. Instead of going from a point to a line, we're going to find the distance between two parallel lines. So let's say you have train tracks. We're going to calculate the distance between two parallel lines. So one line is y equals x plus 3, and the other line is y equals x minus 4. And again, I want to know the distance between those two lines. Are those lines parallel? Yes? How do you know? Because I said so? Is that what you said?
You're crazy.
If I didn't tell you that those lines are parallel, how would you know they were parallel, Miss Smarty Pants? Go ahead. They have the same slope, correct. This problem doesn't work if they have different slopes, because then the points would, or lines would intersect. It's what we did 2 days ago. Okay, this is parallel lines. Now here's the weird thing. All of you can do this completely differently and get the same answer. It allows a certain amount of creativity. Hi, welcome to high school. Would you like to act your age? Attaboy, good. Okay, so you have to make a decision. Simon, we're going to pick on you. Which line would you like to use? And no incorrect answer, top line or bottom line.
Can we use the top line?
We can use whichever one you'd like. You'd like the
Let's
top
use
one?
The top line.
Okay? What I need from you then, Simon, is a point on that top line. And here's where the creativity comes in. You can pick any point you want, as long as it's on that line. What point would you like to use? Let me interrupt before you give me an
Sorry,
answer.
no,
There are some, well, that too, we'll correct that in a second. There are some smart points to choose, and there are some points that, while creative, will make your life a living hell. What, once again, without using what point would you like on the line y equals x plus 3?
Can we use 3 and 6?
Sure. 3 and 6 good for everybody?
Yeah.
You don't care because you're going to pick your own points later. Oh wait, hold on a second. You said 3 and 6? 3, 6?
Yes.
How do you know that's on the line?
Don't
You just guessed? You randomly picked 2 points that generated a point that's actually on the line? Do you understand the odds of that? Astronomical. You should play the lottery. Except you're underage and you can. You should give money to somebody to play the lottery for you.
Or make a few.
Yeah.
0.3.
You're just shouting out random numbers? Oh, you want to use a point 0,3.
Yeah.
Okay. Another possibility would be 0,3, and I'm going to ask you the same question. How do you know that that point, which is on the line, is on the line?
Because 3 is the y-intercept, so it's
Okay, but what about in Simon's case? That's not the y-intercept.
what?
How do we know that Simon's point is also on the line y equals x plus 3?
I don't know that his is, but I know.
Oh, so you don't trust him? I think she just called you shady.
My parents don't even trust us.
That hurts. That hurts. Herman, what do you got for me?
I think 3, 6 would be on the line because the slope is 1, and if the y-intercept is 0, 3, and it was to move 3 to the right, you also have to move 3 up, becoming 3, 6.
A correct answer, but way too complicated.
If you plug the points into the equation,
You plug 3 in for x, you get 6 for y, we're happy. What point isn't on the line y equals x plus 3? Go ahead.
Negative 72 and 0.
Correct. Good. Okay. But since you started this, Simon, we'll stay with 3, 6. Okay? Now, to make sure things don't get out of control, once you've picked your point from one of the lines, you cross out this line. Because you will not come back to that line ever again. If you forget to cross it out, you stand the risk of using that line for some calculations, and that's going to cause a whole world of hurt. All right. Doing that simple step has now turned this problem into a problem like we just did. Okay, so what's going on? I've got a line now here. Looks something like this. In fact, the picture will look amazingly like the last picture. And then over here, I've got a point at 3, 6. Simon, what would you like to call this point?
Let's call it S.
S.
Yeah.
For salamander.
Or Simon.
Or Simon. Okay, good. You're both animals. It's a true. He's not a vegetable or a mineral. He's an animal. Haven't you guys had bio?
He's a
Don't
savage.
you freshmen in biology? Have you not gotten to that point yet?
He's a savage. Humans are
He's an animal.
animals.
He's not a vegetable or a mineral. He fits into the animal kingdom.
He's a savage.
Come on.
Simon, we're going to spare you the grief of bursting into flames.
Okay.
What would you like to call this point down here?
Let's call it N.
N, as in narwhal,
Yeah, because we're both
You're right,
animals.
you're
because you're both animals, yes. Good. And just to keep things above board, we'll call that D for distance, because that's what we're looking for. Okay. Simon, what's the slope of the black line?
Black line.
Yeah, this guy?
1.
Good. So therefore, what's the slope of the red line? Notice I'm calling that slope of the perpendicular because I'm getting all saucy here.
1 as well.
Nope.
Oh, -1.
Attaboy. -1. Flip it over, change the sign. Reciprocal of 1 is 1. It's positive, make it negative. Okie doke. Two things we need for the equation of a line are
The slope and 2 points.
a point,
A point.
a point. Do we have a point?
Yes, we do.
Do we have a slope?
Yes, we do.
Outstanding. What would be the equation then of the red line?
Sorry, let's restart that.
Okay.
Y minus 6
Uh-huh.
equals -1 quantity x minus 3.
Outstanding. And so now, in order to find n, we need to solve the system. So I include my braces, which says, yo, I'm solving a system between these two lines. Oh, Simon, what method would you like to use here? Substitution or elimination?
Sorry, can we restart that?
Okay.
Can we use substitution?
We can use whatever you'd like. I'm here for you. buddy.
I would like to use
Substitution. I'm assuming, and I might be wrong, but I'm assuming you want to take x minus 4 and sub it into the red equation.
Yes.
Okay, good. Whoops. Oh boy. Yeah, good numbers, Simon. I was being sarcastic. That's a 13. 13 halves. Leaving it in fraction form, I don't want decimals. Okay, we're almost done, Simon. How am I going to find y?
You have to plug it back into
Where would you like to plug it in, the red or the black?
black.
Black. Y is equal to 13 halves minus 4. I can do that in my head, I think. 5 halves. So that means, in a summary statement here, N, not M, N as in narwhal, is 13 halves, comma, 5 halves. We're almost there, Simon. How do I finish the problem now?
Sorry, let's restart that.
Third time's a charm.
Have to do D and then like a subscript S2N equals, and then we have to do the distance formula on the
Knock yourself out. Distance formula will handle fractions. You just do 13 divided by 2, 15 divided by 2. And obviously 3 and 6. And let's go with a decimal value here, not a square root value. Anybody else have it? Just shout it out so we get
4.95.
4.95. We good?
Yeah.
Everybody else? 4.95. Good. If we were to change Well, there's a lot of things we could change when we started the problem. For instance, Simon picked the first equation. He could have picked the second equation. He picked the 0.36, but as we already saw, Jalen, for instance, picked 0.3. You could have picked 113, 116. Things will change if you change that starting information. The system will change. The points that you find will change. What's not going to change is the final answer. So regardless of how you set up the problem and solve the problem, you got to get that for an answer. But Franny has questions.
Should there be units with the final answer?
If units are originally given, yes. If not, you can just use U for units. Okay. If, for instance, we know that Matt is, 4.47 miles away from the river. Okay, you got it? Guess what you get to do tonight? This, right. Okay, now tomorrow we're going to do some more of these. However, they're going to get uglier because we're going to purposely pick some weird numbers and practice a little bit of storing on the calculator as the numbers get uglier and uglier. Okey-doke? That'll be fun, won't it?
No.